There used to be a popular belief, and honestly, I'm not sure how many people still hold on to it, that if Earth were just 1 meter closer to the sun, we'd all burn alive, and 1 meter farther, we'd freeze to death. We even touched on what would happen if the moon disappeared in a previous video. But here's the thing. Our planet already drifts roughly 4.5 million kilometers closer to and farther from the sun over the course of a single year. You could add or subtract not just 1 meter, not even a kilometer, and life would carry on just fine. But I'll take it even further. Even if the sun vanished entirely, life on Earth could potentially continue for billions of years. In fact, I'd argue that deliberately pulling Earth out of the sun's orbit might be something we'll eventually have no choice but to do. Stick around, I'll explain why. The sun was born 4.6 billion years ago. Its mass, 333,000 times that of Earth, began collapsing inward under its own gravity. But just as with every other star, the immense heat generated by the friction and pressure during that collapse stripped the electrons from hydrogen atoms, which make up about 91% of the sun. Those bare nuclei were then forced within a femtometer of each other, close enough for the strong nuclear force to take hold. And they began to fuse. This was the birth of nuclear fusion. As those hydrogen atoms merged, they transformed into helium, and in the process, released enormous amounts of energy for reasons we've explored before. That outward pressure from fusion balanced the inward pull of gravity, and ever since that moment, the energy from that fusion has been powering life here on Earth. We call it an energy source, but would life on Earth even exist without the sun? Honestly, the sun serves one primary purpose in the origin of life. It provides enough heat to keep water in a liquid state. And even that doesn't apply everywhere. Every star has what we call a habitable zone, a Goldilocks region, where liquid water is possible. But liquid water also requires sufficient atmospheric pressure on the planet's surface. The sun's heat alone isn't enough. For our sun, this habitable zone begins at roughly 38% of the Earth-Sun distance and extends out to about 10 times Earth's orbital radius. We'll explore why liquid water is so critical to life in another video. But here's the key point. Even without the sun, a planet or moon could still harbor liquid water. Life on Earth actually began around hydrothermal vents at the bottom of the oceans. The water there is even hotter than the surface, because the sun isn't our only heat source. Earth's core is a massive furnace of its own. That heat rises through magma, warming the water above those vents to temperatures that keep it liquid and life-sustaining. In other words, when life first emerged on Earth, it didn't just not need sunlight. It didn't even know the sun existed. But does that still hold today? After all, we breathe oxygen produced by plants and algae through photosynthesis, a process that runs entirely on sunlight. Could life survive without it? Let's think through what would actually happen if the sun disappeared. First, we need to understand something fundamental. Nothing in the universe acts instantaneously. Gravity feels immediate to us. But remember, nothing travels faster than light. And that includes gravitational waves. So if the sun were suddenly erased, Earth wouldn't notice for exactly 8 minutes and 20 seconds. The time it takes for both light and gravitational waves to reach us from the sun. That's a genuinely strange thought. The sun blinks out of existence, and for 8 minutes and 20 seconds, we'd still see it shining, and we'd still be traveling along our orbital path, covering roughly 15,000 kilometers of an orbit around a star that no longer exists. Out at Pluto and beyond, it would take hours or even days to notice. The outer planets would keep circling a ghost. But once those gravitational waves finally reach us, Earth would break free of its orbit and shoot off in a straight line into the darkness of space. Temperatures would begin to fall. Yakutsk, a city of over 370,000 people in Siberia, where December averages around -40 degrees Celsius and the all-time record sits near -64, would start to look like the new global standard. In an optimistic scenario, it would take roughly 400 days for global average temperatures to drop to 0 Celsius and about 879 days to reach -17. One way or another, within months to a few years, Earth would become a frozen snowball. The first living things to collapse would be the plants. The moment the sun disappears, photosynthesis stops. Plants would survive only as long as their stored starch reserves held out. Large trees might last 2 or 3 months. Many smaller plants would die within days. The cascade through the food chain from there is easy to imagine. You might assume the real crisis would be oxygen. But no. Our atmosphere currently holds about 1.2 trillion kilograms of oxygen. A single human consumes roughly 840 grams of it per day. If humans were the only ones breathing, we'd have enough to last around 500,000 years, about 1.5 times the entire span of our species' existence. Of course, other animals breathe too. But as plants die off, herbivores starve, carnivores follow, and most species collapse, along with their oxygen consumption. Evolution simply wouldn't have time to respond to a catastrophe this fast. It would trigger a mass extinction unlike anything in history. But here's the thing. Life is not just animals and plants. Among the estimated 8.7 million eukaryotic species on Earth, they're nothing. A rounding error compared to bacteria and archaea. Nearly all of these single-celled organisms have no dependence on plants, animals, or sunlight whatsoever. And every complex organism you can think of evolved from ancestors that looked just like those simple microbes. Many bacteria and archaea have evolved to thrive in extreme heat, extreme cold, extreme salinity, extreme acidity. They would carry on, completely indifferent to whether the sun exists. Life, at its deepest level, would find a way. And over the next billions of years, it could diversify all over again. But what about us? Could humans survive? Could civilization hold together? Honestly, the collapse of the food chain means our livestock and our crops disappear, and feeding 8 billion people becomes impossible. The vast majority of humanity would not survive, but some of us could. We could grow food using artificial light. We could manufacture nutrition synthetically and produce crops in local enclosed environments. And here's a strange twist of fate. Fossil fuels and nuclear energy would become our greatest allies. Fossil fuels could sustain civilization for thousands of years, nuclear energy for billions. Though we'd have to be careful with fossil fuels because burning them consumes about 1,000 tons of oxygen per second. And in a world with no plants to replenish it, we couldn't afford to be reckless. Fortunately, with human population drastically reduced, the demand for fuel would shrink too. Of course, how well we'd survive an event like this depends enormously on where our civilization stands at that moment. If it happened today, with our fragile, patchwork energy grids and supply chains, many of us wouldn't make it. But if it happened when we were already a Type 2 civilization, one that could harness and direct planetary-scale energy, we could rebuild society entirely within our cities. And who knows, maybe this time around we'd build something a little more humane and equitable. And the truth is, we may not need the sun to disappear for any of this to become relevant. As I mentioned at the start, one day we may have no choice but to leave the sun's orbit on our own terms. Here's why. During fusion, when hydrogen converts to helium, energy is released. And releasing energy means losing mass. So the sun is slowly, constantly shedding its mass. The process is extraordinarily gradual. Over the past 4.5 billion years, our star has lost only about 95 Earth masses out of its current 333,000. But the problem isn't the mass loss, It's what happens inside the sun as hydrogen becomes helium. A denser core forms at the center, increasing the gravitational pressure. So the sun's core has been getting hotter and more compressed ever since it formed. And that rising temperature and pressure accelerates fusion over time. The result? The sun grows slightly hotter and brighter with every passing year. As those temperatures climb, the habitable zone expands outward. But Earth's orbit doesn't move with it. Roughly 1 billion years from now, the heat will be enough to boil Earth's oceans. As water vapor floods the atmosphere, the greenhouse effect will spiral out of control. Our pale blue dot will turn into a parched yellow desert. Eventually, high-energy particles from space will split the water vapor in our atmosphere into hydrogen and oxygen, and both gases will bleed away into space, and Earth's water will be gone forever. And that's still the optimistic timeline. About 3 to 4 billion years after that, the sun's core will run out of hydrogen entirely. With no more core fusion to push outward, gravity will compress the core further, and fusion will ignite in the shell surrounding it. That shell burning will drive the outer layers of the sun outward, expanding it until it swallows Mercury and reaches out to the orbit of Venus. At that point, the sun's core will hit roughly 100 million degrees Celsius, igniting helium fusion. Helium nuclei will begin fusing into heavier elements like carbon and oxygen. This will ease the pressure on the outer layers, allowing the sun to contract again, before expanding a second time, even more violently. Between these two expansion phases lies roughly 100 million years, but the second expansion will swallow Venus entirely and push the sun's edge to somewhere around Earth's current orbit. Whether Earth itself gets consumed, we genuinely don't know, because as the sun bloats and sheds its outer layers, its mass will decrease, weakening its gravitational hold on the planets. As that grip loosens, Earth's orbit will drift outward, and our planet might just barely escape being swallowed. But whether or not Earth gets consumed, the water and the atmosphere will be gone, as I described. And if the sun does engulf us, even the rocks will vaporize over hundreds of millions of years. Earth, and everything on it, would be erased from existence. This is the fate that awaits us if we sit still. We've already cleared every existential hurdle humanity has thrown at itself. Climate change, pandemics, wars. And yet this planet gives us at best 1 billion more years. For context, we've only been here for 300,000 years. Life itself has existed for 4 billion. We have, at most, about 25% of life's total tenure on this planet remaining. If we do nothing, our sun will eventually destroy us. So in the long run, we have two choices: become a galactic civilization and get out entirely, or hatch a plan so audacious it sounds insane today. Convert Earth itself into a kind of spaceship and deliberately steer it out of the sun's orbit. That sounds like the wildest science fiction right now, I know. But if we manage not to destroy ourselves first, we won't have a choice. Something will have to be done. See you in the next one.